thank you for everyone who is participating. Today, we will continue from where we left off, and then we will present a case study of the ongoing Accra Kumasi Road bypasses project. We will walk quickly through a recap of what we did, the geometric design process, geometric design considerations, what they are, and then we will proceed with a case study. We said last week that geometric design is a process starting with the considerations, and then out of the considerations, we get inputs that we use tools around the inputs to generate the outputs of design drawings, setting out information, and others. We also said that the geometric design considerations govern the design process. Geometric design considerations determine the quality of the design output. Geometric design considerations, we said, are normally obtained from terms of reference, design manuals, stakeholder consultations, lessons learned, and of course, design reviews. We walked through a list of design considerations, and I'll run through them just as a list for now. We spoke about functionality, route location, traffic volume, traffic composition, capacity, safety, site conditions, terrain type, land use, mobility and access, stakeholder interests, climate resilience, and economy. We would now look at how these geometric design considerations have been applied to the Accra Kumasi Road bypass. Now, the problem that the bypasses project sought to address is the unacceptable time delays at Osino, Enyinem, Enyiresi, and Konongo. The high vehicle pedestrian conflicts in those towns, high vehicle to vehicle conflicts in those towns, high air pollution in those towns. The key objectives, therefore, were to reduce pedestrian vehicle conflicts in the area of road safety, to reduce vehicle-vehicle conflicts, to reduce travel time, to reduce travel distance, and to reduce air pollution. The preferred solution that the GHA arrived at was the avoidance of these four settlements by bypassing them, and to still connect the towns to the bypass through grade separated structures or interchanges, and also to afford crossing roads, to cross, and those that want to join the bypasses or to leave the bypass to do so. I will, at this point, let Engineer Bernardo Usu, the Highway Design Manager, and also the leader for the design team on this project, to present considerations and then how they were applied from the planning stage through the ongoing implementation stage. Engineer Usu.
Thank you, Engineer Duah. So I'll be looking at functionality and route location. In defining the alignment, a road being a trunk road, national road, says a route was chosen in such a way that settlements will be avoided to limit friction between through traffic and local traffic, and also ensure that there is connectivity. Under consideration is a national road, trunk road, N6, with mobility function. Now, to ensure that this function is achieved or maintained, the alignment was chosen in such a way that settlements will be avoided to reduce the friction between through traffic and local traffic, and also ensure that there is adequate connectivity. Like I said, this road is a national road, N6, and free flow must be maintained as much as possible. And this has been achieved by taking the routes further away from settlements to minimize the friction between through traffic and local traffic, and also provide adequate connection between the trunk road and the settlement. Now, with the traffic composition having high percentage of trucks and heavy good vehicles, gradients which are friendly to trucks, of truck-friendly gradients, have been chosen so that they can climb without adverse impact on their mechanisms or impact on other vehicles. Now, safety consideration. At the planning stage, as you can see my mouse, this was the original route chosen for the bypass. This section is the University bypass. So originally, we're coming to the existing NSS, then after about a kilometer, we go off before University. However, at the implementation stage, it was observed that the place has been taken over by development, and the rate at which development was going required that the bypass be taken further away so that there will be no conflict or friction in relation to motorized and non-motorized traffic. Terrain type, the alignment goes through a rolling terrain. However, at a particular location, which is the Osino section, as you can see here, the alignment would have gone through a mountain. And this would have necessitated the reduction of the design speed from 100 to about 80 kilometers per hour, resulting in reduction in stopping side distance and increase in slopes. And therefore, to maintain the speed of 100 kilometers per hour, the alignment was shifted to the right-hand side, as you can see with my cursor. So this now is the northbound. As originally planned, this would have been the northbound, and this now is the southbound. Okay, so this is the new southbound. This used to be the original southbound, but the alignment at the planning stage, because the alignment goes through a green belt or a green field, there were some obstacles that were not observed at the planning stage. However, when the place was cleared, things were clearer, and therefore there was opportunity to refine the alignment further to ensure that we don't compromise on any of the standards. Now, in the area of land use, using the same scenario, at that same session, at the planning stage, there were two pylons, but they were not observed at that stage because, as I said, it was a forest and it was difficult to be able to appreciate some of these objects. And therefore, the alignment had to be refined to make sure that utility lines such as these two grid lines will not be affected. So as you can see on the plan, this used to be the original horizontal alignment for the south and the northbound. But to minimize impact on the utility, it had to be moved further away to the right with some reduction in the median to ensure that there's minimal impact on the grid lines. Another case is a mining concession. At the planning stage, it was not realized that the alignment was going through a mineralized zone. After the place was cleared, the owners raised concerns, and we had to quickly modify the alignment so that we avoid the alignment going through the mineralized zone. So as we have here, this used to be the original alignment, and now we have refined it at the planning, the implementation stage. And at this, I want us to appreciate the fact that a design is not cast in stone. The design must fit, it must be fit for purpose, and must ensure that where there is need for change, we change. We should not be rigid when it comes to geometric design. So at the planning and the implementation, you realize that when it comes to land use, you have to appreciate it and make sure that you define your alignment in such a way that there is minimal impact on adjoining properties. Yes, in accordance with the design geometric considerations. Now, mobility and access, then stakeholder interest. The alignment, as I said, or the route, as I said, is a trunk road, National Road 6, with high function of mobility. Now, to ensure this mobility function is maintained throughout the length of the route, grade separations have been provided to minimize conflict, that's cross conflict, then other maneuvers which will hinder the flow of traffic. Now, apart from grade separations for crossroads, interchanges have been provided at 3 to 5 kilometers to enable vehicles who may want to turn around to settlement areas or turn around to other locations of interest. They'll be able to achieve that through interchanges with ramps and other slips. Now, climate resilience, the route goes through a greenfield. And as we are all aware, with the construction, a lot of vegetation will be taken over by the road. Now, to ensure that our alignment is sensitive to the climate, we have left the median untouched. The median, a wide median has been left between the two carriageways untouched, not to be cleared. And to ensure that vegetation that will be cleared as a result of the construction will be brought back. At the fringes of the reservation, trees will be planted, and this will enhance the resilience of the project in relation to climate. Economy. Now, economy is considered at every stage, at the planning and the implementation stage. Now, using the same scenario with the pylon, if we would have stuck with the original route with the cut and the impact on the two pylons, that would have increased the cost of the construction. However, a little change in the alignment to the right-hand side have ensured that the cut that would have done and the pylons that would have relocated have all been dealt or avoided. And by so doing, cost has been reduced or been brought down. In the same vein, very simple grade separation, simple two-tier interchange have been adopted with short span bridges and ramps on embankment instead of viaducts to ensure that cost is controlled. Thank you very much.